Okay, I'm going to repeat some of the things I did say earlier. When working with the dilation, your dilations are always going to be similar. One thing I did not say that I'm going to say now is corresponding sides will always be parallel. Do you see how this line is parallel to that one? Yeah. And this line here is parallel to this one here. Corresponding sides will always be parallel as well. Okay, so the scale factor is always new over old. That's where we got the 2 over 3. And the 8 came from, you guys told me to add 6 plus 2 is 8, so it's 8 over 2. And we're here on number 3. It's a reduction because the dotted line is smaller than the solid line. 14 over 7 or 7 over 14? 7 over 14. New over old. Which one's the new? 7. 14 is the old. What does that reduce to? 1 over 2. Shh. Is that less than 1 or greater than 1?
Wait, do we have to put less than 1 if it's less? Oh, that's awesome.
All right. Next one. The dotted is the new image. The solid is the original. Did it get bigger or smaller? So we would say that is an enlargement. And let me give you the numbers. This here is 3. And just this dotted line right here is 3. Now tell me where I am messing up. If I say it didn't get any bigger because it's 3 and it stayed 3, therefore it stayed the same size. Where am I messing up? I'm not counting right? You're right, I'm not. Yes. I add them. What is the total length here? 6. Okay, 3 over 6 or 6 over 3? It's going to be new over old. 6 over 3 reduces to 2 over 1. Is 2 over 1 bigger than 1 or smaller than 1? It's greater. Now, on your assignment today, on your worksheet, you don't have to put the greater than 1, less than 1. I'm just doing it in notes so we can recognize. These two were less than 1s and they were both reductions. These two were greater than 1s and they're both what? Enlargement. So what happens if you have a scale factor of 2, 3, 4, 5? What's the image doing? Getting bigger. If your scale factor is like 1/2 or 1/3 or 2/3, it's getting smaller. Scale factors are never negative. Everybody hear that? Are scale factors ever negative?
No.
No, always positive. And they're going to be bigger than 1 or smaller than 1. What does bigger than 1 mean? The image is getting bigger. And if it's smaller than 1, it is getting smaller, reduction. All right, questions on this before we move on? Okay, back page. Have you guys plot A, B, C. Do not connect the dots because I'm going to get you guys some rulers. So right now, just plot the A, B, C. I do not want you guys smacking the rulers on your desk, up and down your spiral notebooks. I do not need all the noise making, just act your age. Right now you're just plotting ABC. Use the rulers that I'm handing out to you to connect.
breath. Please. Put it there.
All right. Did everybody plot? -10, 8. Thank you. What is she doing? Thank you. All right, is this what you have, your ABC? All right. Everybody have this on their paper. Okay, next thing I want you to do is plot the center of dilation, which is -12, -10. Okay, what is the scale factor they're asking us to use? 2. Is the image going to get bigger or smaller? How much bigger?
2.
Twice as big. Now, where the image ends up, it's going to be twice as big. Whether it ends up over here, over here, over here, right in here, all of that depends on where your center of dilation is. Okay, so I'm going to show you how to do it, and I'm going to talk to you about what you need to know for the test. Okay, I'm going to do B first because it's a little easier to explain on B. Now, it doesn't have to be rise and run or rise over run. Just have to count how far up and over you go. So from my center of dilation to your point B, can you guys count how far up and over? Do that right now. Count. Up 8 over 2. Okay. Now what you're going to do is you're going to do the up 8 over 2 twice. Count starting from here. Up 8 over 2. That's your first time. From this point, you're going to do it again. That there is your B prime. Did you guys get -8/6? Yes, so what do we do? Up 8 over 2, that's the first time. Up 8 over 2, that's the second time. What if the scale factor was 3? What would I do? Up 8 over 2 one more time. But right now, the scale factor was 2, not 3. If it was 3, I would have gone again. Okay, are we good? Now, let's go ahead and count from here to A. Up and over. How far up, how far over? 2, 2. So we're going to do that a total of 2 times. First time gets me to point A. Then I do it again, up 2 over 2, and this is A prime. Okay, can you guys count up and over to get to C? Is it 12? Up 2 over 10? Okay, so you do it once, up 2 over 10, that gets you to your point C, and then you do it again, up 2 and over 10. And that is your C prime. And then connect your A prime, B prime, and C prime. you have to count up to, was it over 10?
Yeah.
And then up to over 10. Mine ended up at 8, negative 6, 7, I can't tell. Negative 6? Okay. Now, things you should recognize that I told you you would have to recognize for the test. What is AB's corresponding side? A prime, B prime. And recognizing that corresponding sides are always parallel. Okay, what is AC's corresponding side? A prime, C prime. And is that, can you just by looking at it also tell that that is parallel? Okay, the hypotenuse, the BC. What is BC's corresponding side? B prime, C prime. And is that also parallel? Yes. So when you have dilated images, dilations, will the corresponding sides always be parallel? Yes. Will the two figures always be similar? Yes. Okay, let's take a look at our side lengths. Can you guys count, just count, tick, 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 the length between A and B? Go ahead and do that now. Find the length of AB. What is it?
6.
And count the length of AC.
8.
8. Now count the length of A prime, B prime. 12. What's the relationship between 6 and 12? Twice as big. Coincidence? No. How did that happen? Because the scale factor was 2. So without counting, what do you think the length of A prime, C prime is going to be? 16. And if you were to count it, it really truly is 16. Now, as a quick side note down here at the bottom, I'm going to review with you because they will ask you this on today's assignment. They will ask you to find the perimeter. How do I find the perimeter? I add up 6 plus 8 plus the hypotenuse. Do I know the length of the hypotenuse? Do you guys remember what you used last year to find the length of the hypotenuse? A squared plus B squared equals C squared. Will you need to do that on today's lesson, today's worksheet? Yes, C is always your hypotenuse. So it's 6 squared plus 8 squared equals the hypotenuse squared. What is 6 squared? 6 times 6 is not 12. 6 times 6, 36. Plus 8 times 8 is equals C squared. 36 plus 64. Can anybody do that in their head? 100. And then what do I do to both sides to solve for C? The little square root thing? Yes. The square root of C squared is just C. And the square root of 100 is 10. So I can erase this C now and put 10. Now why would you do this? Because they're going to ask you on your assignment, on your worksheet today, to find the perimeter. What's 8 plus 6 plus 10? 24. They're also going to ask you to find area. So in this little bubble here, I'm going to review with you what the formula is for the area of a triangle. You learned it back in elementary school. Anybody remember it? Bless you. 1/2 base times height. My other class said base times height divide by 2. Is that the same thing?
Yeah.
Yes. Can you guys please stop playing with the rulers? All right. So let's figure it out. Area is 1/2. Now when you do base and height for a triangle, you have 3 sides. Which one's your base and which one's your height? Your base and height always have to be perpendicular to each other. So what's your base and height for this picture right here? 6 and 8. Am I going to use the 10 at all? No. When you're dealing with the area of a triangle, your base and height are always perpendicular to each other. Okay, so what is 6 times 8? 48 cut in half. These coming out to be the same as a coincidence. It's not going to always happen that way. It just happened on this problem. Remembering perimeter is units and area is units squared. Okay, questions on anything that we've done so far? All right, I'm going to come back up to this one and talk a little bit about this point of dilation. I had a few kids that were confused with this my last class, saying, I don't get what that point is. Like, what's the purpose of it? It doesn't do anything to my image. That's how we find where the bigger one's going to be. Regardless of where my center of dilation is, if the scale factor is 2, is it always going to be twice as big? Yes. It depends on where this is, determines where the image is going to be, where it's going to end up. I will tell you this. Right now, I just want you guys paying attention. Put your phones away. This is going to be a test question. They're going to not give you that point. They're going to give you 2 images like this on graph paper and to ask you to find the center of dilation. Everybody hear that? They're going to give you on graph paper 2 images like this, and they're going to ask you to find the center of dilation. So this here will not be given. And I'm going to show you how to find it. Are you ready? What you do is you take your ruler and you line up. Right now you're just going to listen and watch. You're not going to do it with me. You're going to line up B and B prime. And connect. Then you're going to line up A with A prime and connect. And then you're going to line up C with C prime. And where do they all intersect? At the center of dilation. Does that make sense? Yes. And that's always going to work that way. When you have your dilated images, your original and your dilation, and you connect A with A prime, B with B prime, C with C prime, they're always going to intersect at the center of dilation. I want you guys to go ahead and draw on yours now. You will have to know that for the test. It what? All right, when you're done with that, go ahead and plot the 8-7, the 9-13, and the 13-9. This one down here. Go ahead and plot those on and connect. Again, when you're done with all the stuff that we just did on the other side, you're drawing your new image, your number 2. And the center of dilation is 13-12. All right, everybody have it? What's the scale factor for number 2? 3. So we're going to count everything. It's going to end up, if it's 3, if 3 is bigger than 1, is it going to get bigger or smaller? How much bigger? 3 times as big. All right. So let's see. I'm going to do this point to Z. Can you guys count from the center of dilation to Z, how far down does it go? 3. Put your phones away, guys. So you're going to do that a total of 3 times. So down 3 to Z, that's 1 time. 1, 2, 3, that's the second time. 1, 2, 3, Z prime, that's the third time. Okay? First time, second time, third time. Count down and left to get to X. How far down and left do you have to go? Say it again. Down 5, left 5? Yes, to get from here to X, do we all agree it's down 5, left 5? Okay, so you do it once. The first time you do it gets you at point X. Then you have to do it again. And that gets you right here. What is that? 3, 2. And then you do it one more time or stop here?
One more time.
That put me at -2, -3. Anyone else there?
Yeah.
Okay, that is my X prime. Now the only point I have left is Y. How far up and left do I go to get to Y? Up 1, left how far? Okay, that's the first time. Up 1, 2, 3, 4, that's the second time. And my last time is at 1:15. Anyone else there? And I stopped there because that's the 3 times for the scale factor. All right, connect. All right. What can we say about corresponding sides? They are always going to be what? Parallel. And are corresponding sides going to be congruent or proportional? Proportional. What's the scale factor going to be in this one? We know it already. They gave it to us. What is it? 3. And does it look like it's 3 times bigger? Yes. Now, I'm going to have you practice really quick. Connect Y with Y prime, X with X prime, Z with Z prime, and see if it does intersect at the center of dilation. Did it work? Okay, I'm going to have you guys do 3A right now on your own. Go ahead and do it. You'll have a few minutes to do that now. Right now, you guys are all graphing number 3. What shape do you end up with once you connect your 4 dots? Not a square, but a rectangle. And what is the scale factor? Is it getting bigger or smaller? How much bigger? 3 times as big. And when you are done graphing the 2 images, I want you to find the side links for all of it. Find the side links of your original side, your original image, and then find your side links, your length and width for your dilated image. So finding length and width for all of them. All right, you guys done? All right, we're ready to see the picture? Yeah? Is that what you guys ended up with? You're not there? What part? Do you have the small one yet? All right. You can finish it off later. Right now I want to quickly talk about the lengths. What's the length of AB? So there's 4 for CB as well. What's the length of AD? That means BC is 6 as well. What's the length of D prime to C prime or B prime to A prime? Did anybody count it or did you just times it by 3? And does it work? Did anybody count it and double check it? No one did? Yes, you did. And it did work. Okay, what's the length of B prime, C prime? 18 and 18. Okay. Perimeter for the smaller one. 6 plus 4 is 10 and 6 plus 4 is 10. What's the perimeter? 20. Without doing the adding, what do you think the perimeter is going to be for the bigger image? 20 times 3 is what? Can you guys do it really quick? What's 12 plus 18? 30. What's 18 plus 12?
30.
And what's 30 plus 30?
60.
Did it work?
Yes.
Okay. Area. Length times width. Do you guys agree it's length times width or base times height? 6 times 4 is what? 24 for the area. And for the area, the bigger image, what are we going to multiply? 12 times 12 times 18. And when you do that, it comes out to be 216. That's a lot bigger than 3 times bigger. Do you see that? Yeah? Okay, let's figure it out. What is the scale factor? What was the scale factor they gave us? Not here, just the scale factor was what? Not the center of dilation, the scale factor. 3. Now, if they didn't give us that and we had to do new over old, would I do 12 over 6 or 12 over 4? I'm going to do that. 12 over 4 reduces to what? 3 over 1. And is that the scale factor? Yes? Okay. What is the ratio of the perimeter? New over old is 20 over 60 or 60 over 20? 60 over 20. What does that reduce to? 3 over 1. And the ratio for the area, new over old, is 216 over 24. What is 216 over 24 reduced to? Is it 3 over 1? It's not. It is 9 over 1. And I do want to talk about that a little bit because this is on the test. Are we ready? Okay. The ratio, the scale factor, the side lengths, the perimeter, all of that stayed 3 to 1. The area grew up a lot bigger. It blew up a lot bigger than just 3. Why is that? Take a look. What do we know about perimeter? Perimeter is units, where area is what? Units squared. So what's 3 squared? 9. Not a coincidence. So if the scale factor was 4, what would the ratio of the perimeter still be? What would the ratio of the area become? 4 squared is 16. Do you guys see how that worked? What if your scale factor was, say, 3 over 2? What would the ratio of the perimeter be? It would still be 3 over 2. What would the ratio of the areas be? What's 3 over 2 squared? 9 over 4. Any questions?
30 minutes of notes.
I know, it was a long one today. I want you guys taking out your packets that I gave you earlier and starting.